students, I have told you that electrons can move out of the atom and become a free electron. Okay, so how does this charge can be obtained? Okay, electron can move, but how? Electron can move out from an atom, but how? Okay, so here is a question and the answer would be that it can be obtained by the friction caused between the two objects. Okay, if we rub any two objects like this, so the friction between them would get the heat up to the atoms that are present on the surface. Okay, and that heat up would leads to the energy to an atom. Okay, so if we are providing some kind of energy, like let's suppose I'm drawing an atom for you. This is a nucleus part and electrons are moving here in an atomic shells like this. Okay, and if we are providing some external source of energy in any way, okay, but if we are rubbing it actually working as a heat, fine. So by getting this kind of energy, the electrons that are present in an atomic shell and the most outermost shell of an atom, they get excited. Okay, by getting the extra energy, they get excited and eventually they will leave the atomic shell and become a free electron. So this is how this charge can be obtained. And now not only by just rubbing these two objects, if solar energy is directly in contact with the any kind of atom or any kind of object, the surface area would get heat up and that heat actually would leads to the same phenomena. Okay, so here this is how charge can be obtained. This is the most famous example that we see and we used to play with also. Okay, like when we used to comb in dry hairs, so the comb that actually get rubbed by the hairs get heat up. Okay, little bit of heat up because of friction. The surface of the comb will get friction and the heat energy that is transferred to the particles of this insulator comb, plastic comb, will give the electron free. Okay, now these free electrons, because this is an insulator, won't be able to move here and there, so they will actually sustain on the surface only. Okay, if this would be a conductor, students, then they would be like moving from here to there. They can move because conductor can only be able to move the electrons through it. But insulators won't allow electrons or any kind of charged particles to move from one place to another or through them. Okay, now because they get heat up and the electrons get free now, they have become they are present on the charge on the surface of the part of the object, fine, like this. And whenever we put through we get it near to the pieces of paper, so they will attract the pieces of paper because of the charged particles that are present on the surface. They will attract the pieces of paper now. Okay, these some examples also are present, like when we rub some silk cloth with a glass rod, okay, ebonite rod with a wool, they would also get these kinds of charges and they will attract different particles, different things around it. These kinds of things are obtained by the friction mainly. Okay, so here is another thing that we're going to see, that different rules of charging. What are different rules of charge? Okay, so charged particles are mainly of two types, positive and negative charged particles. So in the same manner, we are having two rules here, that like charges repel each other and the unlike charges attract each other. Okay, like charges means that the charge could be of same charge, like if we are taking negative charge, then the other one will be negative only, and if we are talking about positive, the other one would be positive only. If they are like if we are placing two negative charge particles between a certain gap, okay, there is a certain gap in between them and there is a certain gap in between them, but that gap is not too big, okay, that would actually repel each other. Okay, having certain distance between them. Now, if we are taking different unlike charges like positive and one is negative, if negative and another one is positive, they will attract each other. Okay, so this is a rule of charges. Negative and negative will repel, positive repel. That means like charges repel each other and unlike charges attract each other.